This lesson is from Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.2, applications of right triangles. So if you want to go ahead and get that lesson open, we'll get started.
I'm going to do it anyway.
Okay, so yesterday we started by talking about some basic applications and how important it is to make sure that you draw out these pictures that go along with the word problems. So we're going to go on to another example today. So this example, we're going to be talking about the rafters for a house. So this is actually a real-life application, and this does get used in the construction business. House framers can use trigonometric functions to determine the lengths of rafters for a house. They first choose the pitch of the roof, or they calculate the length of the rafter needed for the house. Matt is constructing rafters for a house, for a roof with a 10/12 pitch on a house that is 42 feet wide. Find the length x of the rafter of the house to the nearest tenth of a foot. All right, so what we're going to do is we're going to start by drawing a picture of the circumstance. Okay, so we know that the pitch of a house, or the roof line, is kind of like an upside down V. Okay, so here's my house, right? I know it's not a very good house, but we can pretend. Oh, really bad house. Let's try this again. You're taking your test, no talking. Okay, so here is the rafter that we're dealing with. Okay. And what I'm going to do is I'm just going to build a right triangle from this roof line. I know that right here we have 21 feet. The reason I know that is because this entire width, that's the width of my house, which was 42, which means half of it's going to be 21. I want to know the length that the rafter needs to be. So here's where I'm working from. Okay, so we know, well, what we first need to do is we need to find the angle, this angle here, theta, that the rafter makes with the sidewall. We know that the rise is 10 and the run is 12. We said the pitch was 10/12. So we can use our tangent function to set up, or to find the angle that corresponds with this pitch. Okay, so we're going to use our tangent function to find this pitch. So, I know to find the angle, we use the inverse. And this is going to give us a pitch, or an angle, of 0.833. Okay? Or, I'm sorry. This is 0.833. My apologies. Alright, so when I take the inverse, I get theta to be approximately 39.8 degrees. Okay, so again, we got that rise over run. Rise is 10. Run is 12. So this is your opposite over adjacent, which is why we use tangent. Okay, so now that we have this angle here, what we can do is we can use another trig function to find the length of the rafter. Okay, from this angle, we're dealing with adjacent and hypotenuse. The trig function that goes along with adjacent and hypotenuse is going to be cosine. So here's step 1. Step 2. We're going to use cosine of the angle, which we just determined to be 39.8. And that's going to equal adjacent over hypotenuse. So now what we can do is we can multiply both sides by x. And then divide over our cosine of 39.8. So when I put that into my calculator, I get a length of approximately 27.3, and that's going to be in feet. Okay, so the length of the rafter for this house is approximately 27.3 feet. Okay, so the next thing we need to talk about is angle of elevation and angle of depression. The angle between the horizontal and a line of sight, so line of sight meaning looking straight ahead, the line of sight above the horizontal is called an angle of elevation. So if you were to look up, the angle created with the ground and where you're looking, okay? The angle between the horizontal line and the line of sight below the horizontal is called angle of depression. So let's say you're standing on top of the building and you were looking down. The angle at which you were looking down would be your angle of depression. All right, so let's look at our next example. Gondola aerial lift in Colorado. Okay, so there's a free gondola ride that provides a spectacular view of the town and the surrounding mountains. Gondolas that begin in the town at an elevation of 8,725 feet travel 5,750 feet to Station St. Sophia, and the whole altitude is 10,550 feet. They then continue 3,913 feet to Mountain Village, whose elevation is 9,500 feet. What is the angle of elevation from the town to St. Sophia? And what is the angle of depression from the station to St. Sophia to Mountain Village? So what we're going to have to do is we're going to have to build our triangle. Okay. All right. So here's my town. We know that the gondola ride is going to take us up, and it's going to take us to Station St. Sophia. We know that we traveled 5,750 feet. Okay. We know that that is at an altitude, so that's our height, of 1,825 feet. And what it does is it creates this right triangle. We want to know from here, from the town to Station St. Sophia, what my angle of elevation is. Okay. Now, we'll take this one piece at a time here. So since we have an angle and we're dealing with the sides opposite and the side hypotenuse, we're going to automatically go to our sine function. So we're going to say sine of theta is equal to our opposite, which is our altitude, over our hypotenuse, which is the distance we traveled on the gondola. Okay. So what we're able to do is since we're looking for the angle, to just go ahead and take the inverse of this value, of this quotient. And that's going to give us, when we put it into our calculator, approximately 18.5 degrees. Okay, so that's going to be your angle of elevation. All right, so part B said that we wanted to find the angle of depression from Station St. Sophia to Mountain Village. So from Station St. Sophia, we traveled down to Mountain Village. So we're going to create a new right triangle. Okay, so here's Station St. Sophia, and we're going to travel down to Mountain Village. Okay, still have our altitude. Our altitude is still the same. But this time we've traveled 3,913 feet. Here is my line of sight, looking straight out, okay? This would represent my angle of depression. We're going to call it beta. All right. Here's my angle of elevation. Here's my angle of depression, looking down. So we're going to figure out how we can determine this value. Now, notice something about my line of sight and the base of this triangle. They're parallel lines. Because they're parallel lines, I can say that this angle of depression is equal to this angle here. Okay, so this is also beta. All right, so when parallel lines are cut by a transversal, alternate interior angles are equal. Okay, so we're going to go from this angle and we're going to figure out which trig function to use. We're dealing again with opposite and hypotenuse, so that's going to be sine beta, opposite, over hypotenuse. So again, we go ahead and take that inverse. And when we put that into our calculator, we get approximately 15.6 degrees. Okay, so our next example talks about the height of a bamboo plant. Bamboo is the fastest growing land plant in the world and is becoming popular wood for hardwood flooring. It can grow up to 4 to 6 inches per day and reaches its maximum height and girth in one season of growth. The estimated height of a bamboo shoot. To estimate the height of a bamboo shoot, a farmer will walk off 27 feet from the base of the tree, and he estimates the angle of elevation to the top of the shoot to be 70 degrees. Approximately how tall is the bamboo shoot? Okay, so again, we have to build our triangle. Okay, so here's my bamboo tree, right? He's walking off from the base of a tree 27 feet. Okay. He's stating that the angle of elevation from that base of a tree is 70 degrees. We want to know the approximate height of the bamboo tree. Okay. So again, we're looking at the sides that are being used. What we have here is opposite and adjacent, which tells me to use tangent. Okay. Tangent of the angle, which we know the angle is 70, equals opposite over adjacent. So we're going to go ahead and multiply 27 feet times tangent of 70. And when we put this right into our calculator, we get approximately 74 feet. So the height of the bamboo shoot is approximately 74 feet. Okay, distance to a forest fire. A forest ranger at point A sights a fire directly south. A second ranger at point B, 7.5 miles east of the first ranger, sights the same fire at a bearing of south 27 degrees, 23 west. Okay, so this is in your degrees, minutes, second notation. We did a little bit of work with this before. So what we're going to do is we're going to use this to help us convert to our regular degrees, so it's easier for us to see. So we do have to set up the picture. Okay, so we have a forest ranger at point A. So let's draw point A. Oops. Okay. Sights a fire directly south, so straight down. Okay, there's my fire, F. A second ranger at point B, and he's 7.5 miles east of the first ranger. Sights the same fire, so he's looking at the same fire, at a bearing of, here's my bearing. This bearing is like another word for angle, okay guys? Of south 27 degrees, 23 minutes west. How far is A from the fire? Okay, so we're looking for this value here. Okay, so I'm going to backtrack here. Sorry about that. We're not going to put this here. Bearing. Okay, we talked a little bit about bearing before. So when we're talking about bearing involves a reference to north-south line using an acute angle. So if I'm talking about a bearing, I have to go north-south being up and down. So it's got to be here. Sorry about that, guys. I got ahead of myself. Okay, so that's got to be here. So the bearing is actually this piece here. Okay, so again, bearing is north-south. Okay, so from B straight down, the angle it creates. So what I need to do is I need to find this. Okay, now if you notice, this makes, by drawing that parallel line to X, this makes a right angle. Okay, so way back in elementary school, we talked about something called complements. Complement meaning that they should add to be 90 degrees. So what we need to do is we need to find the complement in order to find this angle here. To find the complement, we simply subtract 27 degrees, 23 minutes from 90. Okay, so we can do that right in our calculator. I'm going to insert a calculator page. I'm going to do 90 minus, and I'm going to use my template, 27 degrees, 23 minutes. And we get not what I want. Okay, hold on. Okay, sorry about that, guys. I had my calculator in this first one. I had my calculator in radians. I need it to be in degrees, so I had to make that adjustment. So when I put this into my calculator, I find it to be approximately 62.6 degrees. Okay, so I'm going to go back here. So again, 62 degrees. Give me a little bit more room. All right, so 62.62 degrees is the complement. Okay, so now we're using our basic right triangle trig. So we're dealing with sides opposite and adjacent, which is going to tell me to use our tangent. So we're doing tangent of 62.62 equals opposite over adjacent. And go ahead and multiply. And we get approximately 14.5, and our units in this case is miles. Okay, so firefighter A is approximately 14.5 miles from the fire. All right, that is all the time we have. We will do the last example in class tomorrow, and I will see you guys then with any questions. Thank you.